Hi, my name is David, and we're going to explain real application for circuit theory. So in our case, it's an FM transmitter, so we're going to explain how it works. We have here the circuit diagram and explanation. So basically we use resistors, capacitors, and inductors from this type of transmitter. There is one transistor that will control the current in the circuit, and we have the battery of 9 volts. So we can see here our tank circuit, which consists of capacitor and inductor in parallel. And we have a variable capacitor. This is an important piece of the circuit because this capacitor will filter all the other frequencies that we don't need. For example, the higher frequencies and the lower frequencies too. So how does a cylinder tank circuit works? So we're going to explain with a schematic process of the transmitter. So we have the premodulation, the amplification, and the transmission. So we have to take the input signal, that will be voice or sound, and we have to modify that. We have to put the signal into a carrier, and then we have to modulate the signal and then transmit the signal. So we're going to get the different equation from our tank circuit, and there is. So as we can see here, we have the inductor and the capacitor in parallel. So as we know, we can apply the Kirchhoff law here. So we have this equation, V sub C minus V sub L equals to 0. So we also know the voltage in the inductor and the current in the capacitor. So if we combine these equations, we can obtain the second grade differential equation for the tank circuit. Now we're going to solve it. So if we want to solve it, we have to apply the Laplace transform. So we have this expression here, and finally we can solve that and go back to the time domain. We can obtain an expression for the current in terms of time. So how can the resonance frequency of an oscillating tank circuit be calculated? So as we mentioned before, the tank circuit is just an inductor and capacitor in parallel. So we can obtain the frequency resonance as another circuit. So we have here the expression from the frequency resonance. It will be W equals to W sub 0 equals to 1 by the square root of LC. So these are constant, and we have to determine which values of these components is the better for our project. So there is my partner going next, and thank you for your attention.